Hello again, everyone. This is part two. Last video, we looked at multiplying different powers, and now we're going to look at dividing, right? Our goal was to multiply and divide powers using exponent rules. So I'm going to review three things. We're going to kind of combine these three things to talk about how we division. First thing I want to review is that fractions mean division. 1 over 3, 1/3, can be read as 1 divided by 3. That's what that fraction bar means. It means to divide. The second rule is anything divided by itself is 1. 7 divided by 7, that's 1. X divided by X is 1. 18.5 divided by 1, or divided by 18.5 is 1. Anything divided by itself is 1. Important rule. The last rule that I want to review is that multiplying by 1 does not change anything. So 1 times 5 is 5. 1 times X, just X. 1 times 100, just 100. Multiplying by 1 doesn't change anything about the number that you're multiplying it to. So let's look at an example here. I have these two powers here. And again, we want the bases to be the same. So we have a base of 3, base of 3. Awesome. We are off to the races here. So 3 to the power 6 divided by 3 to the power 4. So another way to think about this is, again, using our exponent rules. 3 to the power 6 means 3 is being multiplied by itself 6 times. So I need 6 3s. It's 4, 5. Let's squeeze this last one in here. 6. 3 to the power 4 means 3 is being multiplied by 3, and there should be 4 of them. So 3 times 3 times 3 times 3. Okay, so remember what I just said with this rule here, right? Anything divided by itself is 1. So let's look at how many times can we make 1. Here I have 3 divided by 3. Okay, so that's 1. And we agreed that multiplying that by 1 doesn't change anything, right? So 1 times 3, well, it's just 3. So I'm just going to cross it off because I don't want to deal with it. Let's see how many more times we can make 1. Well, here is 3 times 3, or 3 over 3. So that's 1. Okay, can we do this any other times? I'm finding pairs in the numerator at the top of the fraction and the denominator at the bottom of the fraction. So here's another one. That's 1. And then we have another one right here. Okay, notice I still have 3's in the numerator, but there's nothing left in the denominator, so I can't divide. I'm actually no longer dividing. So what I'm left with is 3 times 3, actually over 1. Like I said, this all becomes 1. I could write times 1 in the numerator, but again, like I said, multiplying by 1 doesn't change anything. So here I have 3 times 3, which is 3 to the power 2. And that's our answer. You don't have to write over 1. Every number is being divided by 1 at all times. It's just not something that you have to write, and that'll come up a lot in this unit. So if you have to divide by 1, just, don't bother writing it, type of deal. Now, some of you may be noticing a pattern here, right? When we multiplied powers, we added the exponents. What do you think we did when we divided powers? How do you take 6 and 4 and use them to make 2? Some of you will notice that you are subtracting, right? So another way to go about this one, and you could do it in the exact same way that I did it up here. You could write it out and then cross things off. But some of you will probably have noticed that the relationship is that you subtract this time. So 5 minus 2. Get you x to the power 3. And that's way easier, right? That is so quicker. The goal is to teach you the hard way and then show you like a nice little shortcut. So 6 minus 4 is 2, and that's why we get the 2 there. 5 minus 2 is 3 here. But what happens when I put a coefficient in front of this here? So if I want to write this out again, this is 6, times x times x times x over 2 times x, right? So here I have 6 over 2. Well, 6 divided by 2, you could use a calculator to figure that one out, or you could just know 6 over 2. That's 3. And then once again, we have these two that kind of become 1 here. And you could have done x to the power 3, 3 minus 1. You could have gotten x squared. We just need to combine these here. This is 3x squared, and that would be it. Now this one's a little bit more complicated. We have 2 pieces here, but we're just going to treat them as kind of 2 separate problems and combine them together. We have x to the power 3 minus 2, y to the power 6 minus 4, and that'll give me x to the power 1 times y to the power 2. That is our answer. That's how we divide powers.